If you judge things from a mathematical perspective, and you throw in probabilities, there is no chance in freezing hell we are alone in this universe of ours. Yet, despite decades of looking at the stars, we're yet to find proof of life anywhere else beyond our planet, be it in the form of microbes, dead or otherwise, or advanced civilizations. Knowing that life out there rather exists than not, our efforts to find traces of it are accelerating. And it's not only NASA working on this. Everybody, from smaller such organizations to private companies, is now knee-deep in the race that may redefine our future. The Europeans, for instance, have a bucket full of plans in place in this field. One of them is called the Planetary Transits and Oscillations, or Plato Space Telescope, and it's scheduled for launch in 2026 with the stated goal of looking at terrestrial exoplanets in orbits up to the habitable zone of Sun-like stars. That would be the planets most likely to host life as we know it, located not too far and not too close to their stars to allow water to exist in liquid form, solid enough and with just the right amount of gravity to be life-friendly. Plato was first proposed in 2014 in the European Space Agency's Cosmic Vision 2015-25 plan as the third medium-class mission. It was first reviewed in 2022, and then it got the thumbs up in the Critical Design Review in 2024, and it's now being assembled at Orbitale Hochtechnologie Bremen in Germany. It took ESA such a long time to develop the telescope because this one is not like the others we know. More specifically, it will rely on a very complex arsenal of 26 cameras to look at the planetary systems lost among no less than 200,000 stars. Each camera has 84.1 megapixels each, and that should generate 2 billion pixel images for the entire spacecraft, something that was never achieved before in a space mission of any kind. All these cameras will be used at once, something European scientists hope will enable a combined higher signal-to-noise ratio and larger field of view than has been possible with previous missions. Pictures of the sky will be snapped every 25 seconds, and every 2.5 seconds for the two fast cameras on board for at least 2 years per target star. This gargantuan effort will result in the world's first catalog of confirmed and characterized planets with known densities, compositions, and ages. That's right, Plato will give scientists here on Earth the ability to measure the size of these planets, find their moons and potential rings. On the menu are first and foremost rocky planets that may be Earth's twins, icy planets, and even giant ones, observed in the usual fashion, by tracking the light variations of the stars as planets pass in front of them. As per ESA, the instrument is likely to return measurements of the planet's radii, masses, and ages. All of this could revolutionize our understanding of planet formation and the evolution of planetary systems, as well as the potential habitability of these diverse worlds. But planets will not be the only things the telescope will eat up. As a side dish, the planet's host stars will be the object of study as well, focusing on something called starquakes, the stellar seismic activity. As said, Plato is scheduled to launch in 2026, and it will do so on board an Ariane 6 rocket departing from the French Guiana spaceport. The rocket will help the 2.3-ton piece of hardware move to the Sun-Earth Lagrange point L2, located 932,000 miles away from our planet in the opposite direction of the Sun. Once at its destination, the telescope will unfold its solar panels and become a sort of winged beast with a 30-foot wingspan. Its main body, or the service module, is where the telescope will house the sun shield and the many systems it needs to work: propulsion, communication, thermal control, attitude control and data management. The cameras will be installed on the so-called payload module. ESA plans to have Plato operational for at least 4 years, but if everything goes according to plan, its service could be extended to 8.5 years. The telescope's findings will be backed by the exoplanetary atmospheric observations that another ESA mission, Ariel, will make starting in 2029, when it is scheduled to launch. The upcoming Nancy Grace Roman Space Telescope will also build on some of the discoveries made by Plato. The most promising discoveries it makes will enter further scrutiny in the hands of the other potent space tools our species currently uses, including the James Webb Space Telescope.